Hello GATE aspirants, welcome to part 2 of GATE Classical Mechanics series. Question number 12. A heavy symmetrical top is rotating about its own axis of symmetry, that is the z axis. If I1, I2 and I3 are the principal moments of inertia along x, y and z axis respectively, then. So we have a symmetrical top and it is rotating around z axis, and this axis is x and this axis is x and y. So by symmetry, Ix will be equal to Iy, so that means I1 will be equal to I2. And now we can use perpendicular axis theorem, so that means Iz is equal to Ix plus Iy, so I3 will be equal to 2I1 and that is equal to 2I2. So here I1 is equal to I2 and I1 is not equal to I3, so option C is correct. Next question. A particle is moving under the action of generalized potential 1 plus q dot upon q square. The magnitude of the generalized force is. So generalized force is equal to d by dt of dou v by dou q dot minus dou v by dou q. This can be written as 1 by q square minus q dot of q square. Now d by dt of dou v by dou q dot. So here we have 1 by q square, so this will be equal to 1 by q square only minus dou v by dou q. So here we have 1 upon q square, so this will be minus of 2, so minus of 2, this will be plus 1 plus q dot upon q cube. So this is equal to d by dt of 1 by q square is minus 2 by q cube into q dot. This can be written as 2 by q cube plus 2q dot by q cube. So first and third term will cancel out and that is equal to 2 by q cube. So option C is correct. Next question. Two bodies of mass m and 2m are connected by a spring of spring constant k. The frequency of the normal mode is. So we have mass m here and here we have 2m. Spring constant is k. Now omega is equal to under root k by mu, where mu is reduced mass, which is equal to m1 m2 upon m1 plus m2. So this is equal to m into twice m upon m plus twice m, which is equal to 2m by 3. So omega is equal to under root k and here we have 2m by 3, which is equal to 3k by twice m. So here option A is correct. Next question. Let PQ and PQ be the pairs of canonical variables. The transformation is canonical form. So Q and P is given. For canonical transformation, Poisson bracket should be equal to 1. So dou Q by dou Q, dou P by dou P minus dou Q by dou P by dou Q. This should be equal to 1. So let us calculate all these values. Now dou Q by dou Q, this is equal to alpha Q raised to alpha minus 1 cos of beta P into, this is equal to Q raised to alpha cos of beta P into beta. Next, P, dou Q by dou P is equal to Q raised to alpha, and this will become, cos will become minus sign, so this sign will be plus sign, into we have beta sin beta P into dou P by dou Q is alpha Q raised to alpha minus 1 sin beta P, and this is equal to 1. So from here we can take alpha Q raised to alpha minus 1 Q raised to alpha and beta common, and we will have cos square beta P plus sin square beta P. This is equal to 1 and this bracket is also equal to 1. So alpha beta into we have q raised to 2 alpha minus 1, which is equal to 1. But on the right hand side we don't have any q term. That means this exponent should be equal to 0. So 2 alpha minus 1 is equal to 0. That gives alpha is equal to 1 by 2. And if alpha is equal to 1 by 2, then 1 by 2 into beta is 1. That means beta should be equal to 2. So that means option D is correct. Alpha is half, beta is 2. Next question. Two particles each of rest mass m collide head on and stick together. Before collision, the speed of each mass was 0.6 times the speed of light in free space. The mass of the final entity is. So we have initial energy some E1. Both are moving with same velocity and they are having same mass. So initial energies will be same. So ER plus ER, that will be equal to some final energy EF. So this can be written as 2 into ER. So 2 into mass energy is mc square upon 1 minus v square by c square. And this is equal to final mass, let it be some m1 into we have c square. Because finally that particle is at rest, so we don't have to consider this denominator there. So this will be equal to twice m c square 1 minus v is 0.6 times, so its square is 0.36 is equal to m1 c square. C square will cancel out. We have twice m upon 1 minus 3.6 is 0.64 whose square root is 0.8. This will be equal to m1. So this is 8 by 10, which is 4 by 5. So this is equal to 5 by 2 into m. So here option C is correct. So these were all the questions from classical mechanics part from GATE 2011 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.